One of the cool things about Arduino is you can read data from pins, as well as being able to output to LEDs and motors and to the serial monitor. You can also read from pins. And we've got digital pins and we've got analog pins. Lots of microcontrollers do not have analog pins, or they don't have as many as the Arduino. So that's one of the advantages Arduino's got over its competition, and one of the things that makes it ideal for managing hardware. In the first example, we're just simply going to light up an LED, and we have the button connected to pin 3, and we have a LED pin on the anode connected to pin 10. We set a Boolean binary value of 0 or 1 to a variable called button state, and that will help us tell whether it's on or off. And in the setup, we set the input to 3, so that's where the pin's going to talk to, and we set the output, the LED, to 10. Really, that should be button and LED. Okay, where was I? In the loop, what we're doing is reading the state of the button and storing it in button state. So button as a digital pin will give you 0, 1, on and off, yes or no, high or low, and that is stored in button state. So when we check it in this if statement, we can say, is it being pressed? Is it high? And that means it's allowing the voltage to go from the 5 volts through into the read, into the input pin. If that's the case, then we tell the LED to turn on. If the LED needs to turn off, we turn it off, and that's because the button state is low, or actually anything other than high. And then we have a small delay, because as you're pressing the button, it can have a false positive, because there's like a halfway point between all the way pressed in and all the way out. So we just give it a little delay to make sure that we're not getting a false positive. Now, analog inputs can be anything from 0 to 1023, so 1024 values total. And we've got an analog pin here set as our input. A0 is our input, and we've got the LED on pin 10. And we set that as the input, that as the output. And then in the loop, what we're doing is reading the input with analog read, and we're converting the number that comes back, 0 to 1023, to a number in the range of 0 to 255, because we're going to use that as our LED brightness. And that simply is output to the serial monitor, and it is set as the analog output on the pin, on the LED pin, so we can actually fade the brightness in and out. If you get 3 potentiometers, if we read 3 analog values, then we just have to add the amount of wiring we've got, but we can actually use those fade values, those brightness values, to set the color of the RGB LED. And again, we're outputting it to the serial monitor, but the main thing is we're analog writing that brightness value from 0 to 255 that we got from the analog read, which is a 0 to 1023. As a bit of fun, I've got an example where you can use the analog input as a battery tester. Now it has to be anything 5 volt or lower because we don't want to burn our Arduino out. But it's very similar again, but instead of using a potentiometer, a pot, to dial the voltage, we're getting it from the actual battery. So you have to put a cable or a wire at the ground and the positive terminals to get that reading. And because we're getting a value between 0 and 1023, we actually need to multiply it by this number that I got off the internet to get the voltage. In the digital example, we used a pull down to pull it down to ground. The pins actually have an internal pull up to stop it floating, so that'll make it high. So if nothing is coming through, no signal is being read, it'll be high. So we can tell if it's an unrealistically high value and chop it off if it's above 990. I saw it floating around 1000, so if you only check for values below 990, it's going to be a battery rather than an empty value. We calculate the volts from the value we get from the analog read times the multiplier. We output that as a string because it's going to the serial monitor. And then we can set the color of the LED. So if it's good, if it's in between, and if it's bad, we output red. And then after the second delay, we set it off. So it'll only light up momentarily, and you have to test it again if you want it to light up again. And then just so it's not bombarding the serial monitor, we have a small delay.